let's solve the division we see on the screen. As we can see, we have a polynomial divided by another polynomial, and to begin with, what we're gonna do is rearranging and completing the dividend and the divisor. So the dividend would be minus x plus x to the fifth plus 3, that is equal to, the biggest exponent is 5, so let's first of all we have to write x raised to the fifth plus 0x to the fourth, as there is no 4th degree or 3 or 2, so that would be 0x cubed plus 0x square minus x plus the independent term plus 3. As we can see, the divisor is already arranged, so let's rewrite the whole division. We would have x to the fifth plus 0x to the fourth plus 0x cubed plus 0x squared minus x plus 3, and here we go with the divisor. This is going to make the next steps much easier. We're looking for a quotient and a remainder. The remainder would be a polynomial with the same or smaller degree than the divisor. So it would be a degree 1 or degree 0 polynomial. Let's begin with the division. The polynomial of the biggest exponent divided by the polynomial of the smallest, of the biggest, exponents of the divisor. So that would be x to the fifth divided by x, that is equal to x to the 1, and that is equal to x to the fourth. And now we have to multiply the x to the fourth by the whole divisor, and that would be x to the fourth times minus 2, that is minus 2x to the fourth, and we write it down of the 0x to the fourth, of course, and now x times x to the fourth, that is x to the fifth. Once we've done this, what we have to do is changing the sign of every term we've obtained by multiplying the x to the fourth, the quotient, times the divisor, and that would be minus x to the fifth plus 2x to the fourth. And now let's add these two polynomials. X to the fifth minus x to the fifth, 0. 2x to the fourth plus 0x to the third to the cubed, plus 0x squared minus x plus 3. And now we have to repeat the whole process, and we'll be doing this until the degree of the remainder, the dividend, is smaller than the degree, and that would be the remainder. Now 2x to the fourth divided by x is equal to 2 times x cubed. So let's multiply this 2x cubed by the whole divisor, that is 2x to the third times minus 2 is minus 4x to the third, and 2x cubed times x would be 2x to the fourth. And now let's change the sign. So operating this, we would have 2x to the fourth minus 2x to the fourth is 0. 0x cubed plus 4x cubed is 4x to the third, plus 0x squared minus x plus 3. We have another new dividend, so let's repeat the same steps. 4x to the third, the biggest exponent, divided by the x of the divisor. We will have 4 times x squared, that is 3 minus 1, 2, x squared. Let's multiply this 4x squared times the divisor, and we would have minus 8x squared, and x times 4x squared is minus 4x squared. Changing the sign, we would have minus 4x squared plus 8x squared, and adding this we would have 8x squared minus x plus 3. Let's repeat the step again. 8x squared divided by x would be 8 times x, and multiplying this by the divisor would have 8x times minus 2 is minus 16x, and now 8x times x is x squared. Changing sign, we'll have minus 8x squared, and that would be 0, plus 16x, and this would be a new polynomial, 15x plus 3. Dividing it again, we will have 15x times divided by x is 15, so 15 times minus 2 is minus 30, and 15 times x is 15x. Changing the sign, we will have minus 15x, that is 0, and plus 30. So the remainder is 33, because we cannot divide it again by the divisor, because the degree of the divisor is bigger than the remainder. This would be the remainder, and up there we will have the quotient.